lesson 19, tree diagrams. All right, so first off, let's cover, well, what are tree diagrams, right? Tree diagrams are a chart made of nodes that are connected by branches or lines. So they are another way to show all the possible outcomes of a probability experiment. So they look like there's a lot going on, but once you know how to read them, they're really not that bad. So this appears kind of where you're starting, right? So here, say I was rolling a dice. If I were to roll a dice, I could roll either a 1, 2, 3, 4, 5, or 6, right? So those are all the different outcomes that I have once I roll my dice. Then say I am spinning a spinner and I could land on blue, red, or green. Well, depending on what number I land on first, I have an opportunity to roll a blue, red, or green after each one of those numbers. Right, so say I rolled my dice, I got a 3, and then I landed on green. That would be one of the possible outcomes based off of this diagram. Now, tree diagrams can be shown in different ways. I would say this one right here, this flat one, is the most common. However, they can also look like this. This one looks maybe a little bit more complicated, but it's still the same concept. Here, you're starting in the center, right? And I could roll either a 1, 2, 3, 4, 5, or 6. Based off of whatever number I roll, I could also spin a blue, red, or green. And there's one other one, which is a vertical one like this. So here I'm starting off here on my left. I can again roll a 1, 2, 3, 4, 5, or 6 from my dice, and then I could spin a blue, red, or green. Now, another thing that's super cool about tree diagrams is that if you were to count all of the different options that you have on the bottom, that's your total number of outcomes. So if I were to roll a dice and then spin a spinner, I could have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 different outcomes. Alright, so let's talk about how to create a tree diagram. Here's a scenario that we have. Flipping a coin, then flipping a coin again. Well, if I am flipping a coin, I could either land on heads or tails, right? So that's my first set of branches. I could land on a heads or a tails. If I land on heads, if I were to flip it again, I could land on heads or tails again. So that's my start of my second row of branches. But don't forget that if I also landed on tails the first time, I could land on heads or tails again. So this would be the completed tree diagram for this option. Okay, so the first time you're writing all your possible outcomes, so heads or tails, and then on your second line, I'm doing the same thing, but I'm going to have more, right? I could land on heads or tails again. So here's one that's a little bit more complicated. I am spinning a spinner with 3 equal sections, red, blue, or green, and then I'm rolling a dice. So since I'm spinning my spinner first, I could either land on red, blue, or green, right? Then I'm going to roll a dice. Now when you roll a dice, you could land on numbers 1 through 6. So if I were to spin a red, I could land on 1, 2, 3, 4, 5, or 6. Now, all these outcomes, if I landed on blue first, I would have all the same outcomes, 1 through 6. And same thing if I landed on green first, I would again have 1 through 6 to roll on my dice. So this is what that tree diagram could look like. Again, it doesn't have to be this this horizontal one. You could make it that circle one if you like the circle one or the vertical one. I prefer these because I think these are easiest to read, but again, whichever one you like is fine. Alrighty, outcomes using tree diagrams. So we want to list all the following outcomes from the tree diagram. When you are looking at a tree diagram, here I am flipping a coin 3 times, right? Here's the first time I'm flipping it, the second time, and the third time. To write all the possible outcomes, all you need to do is follow the branches. Okay, so I'm going to start back here at this head, and I'm going to follow it. So I have heads and heads. So my first one is heads, heads, heads. My second one, I have to hit this T, so I'm starting here, going up and down to tails. So I have heads, heads, tails. For the next one, I could start here and go down, head, tails, heads. Or I could go heads, tails, tails. Again, I'm just following every single branch up and down every which way. I could land on tails first, heads second, and heads again. So tails, heads, heads. I could land on tails, heads, tails. And then for the very bottom one, I could go tails, tails, heads. Or I could go tails, tails, tails. Okay, so when you're writing all of your different outcomes from a tree diagram, remember you are just following along all of the branches, okay, until there's no more branches that you have left to cover. Like here we covered all of our branches, I can't go over any other ones. So again, this is the same idea, but this tree diagram is one of those circular ones. So you can start anywhere you'd like, remember, but you're always starting here. So I'm going to spin a roll of 1 and then go to tails. So 1, tails, or I could roll a 1 and go to heads. I could then roll a 2, go to heads. I could then roll a 2, flip a tails. I could roll a 3, flip a heads. I could roll a 3, flip a tails. Now, when you're doing these, you don't necessarily have to go over each of the branches like I'm doing here, but if this visual helps you to make sure that you don't forget anything, I would recommend copying this down on a piece of paper, that tree diagram that you're given, and just going over each of the branches with a pen or pencil. Okay. However, if you start to notice a pattern, right, like here I'm rolling each number twice and then I have a heads or tails after. So you don't necessarily have to go over orange each of the branches if you can see the pattern. Okay, normally there will be a pattern when you are looking at tree diagrams. So here I would have 12 total outcomes, right? Because always count the outermost ring to figure out your total number of outcomes. So I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outcomes. All right, again, this one's a little bit different. Now we want to calculate the probability of rolling an even number or flipping a tail. Okay, so what we're going to do here is let's count how many total options we have, right? So we have 1, 2, 3, 4, 5, 6, 7, 8 total outcomes that we could land on. Now, since this question says rolling an even number or flipping a tails, that means that since there's that word or in the middle, we are going to add our probabilities together. Okay, this we talked about, I believe, in 16 and 17 it went over this. Maybe even a little bit of 18. So I'm going to figure out the probability of rolling an odd number and the probability of flipping a tails, and then I'm going to add them together. So if I look here at my, oops, not odd, even number, sorry. So if I look here, here's a 2, right? So I could either roll a 2 heads or a 2 tails, or I could roll a 4 heads or 4 tails, right? So that's a total of 4 different options, right? Because I have 1, 2, 3, 4. So I would have 4 out of 8. And remember, I got that 8 from adding up everything in this row here. That's my total. That's what goes on the bottom. And then if I look at probability of flipping a tails, here I have 1, 2, 3, 4. So I would have 4 out of 8. Alright, so when I add these together, I would get 8 over 8, which is the same as 1. I read it. Next one says, what is the probability of getting exactly 2 tails? Okay, so for this one, what I want to look at is which one of my branches will I come across 2 tails? Like this first one here, I have head, tails, tails. That's 2. I could have tails, head, tails. That's also another one where I have 2. What about this bottom one? I could have tails, tails, head, or tails, tails, tails. So here, there's actually going to be 4, right? I have this first one, 1, 2, 1, 2, 1, 2, and then 1, 2. So I would have 4 out of 8, or 1/2. So again, it's really just about looking at your tree diagram, following your branches, and seeing which one gives you those 2 tails. So I'd have 1, 2, that's one of my options. 1, 2, second option. 1, 2, third option, and then I'd have 1, 2 again, because regardless of what this outcome is, I already have my 2 tails there. Alright, what is the probability of selecting a red card and then rolling a number that is less than 3? So since it has the word and, that means we need to have both of these conditions matching. Okay, so I can't select a black card and then roll a 1. That doesn't count because I need to roll a red card. So here is my red cards, and if I'm rolling a number less than 3, that is only 1 or 2, which means I only have 2 possible options of that happening. Now to figure out how many total options I have, again, remember that I just need to count all of the last row of my tree diagram. So here I have 6, and then I would have 7, 8, 9, 10, 11, 12. So 2 over 12 would reduce to 1 over 6. Alright, here's our last problem. This one's a little bit trickier. We want to know what is the probability of selecting an outfit that is a sweater, and then you're wearing pants, and you have boots. Now you're probably wondering, what is this 2 over 3 and 1/3 on this tree diagram? What does that mean? Well, this 2 over 3 means that you have technically 2 different pant options and 1 skirt option, right? So 2 out of 3 of your options for bottoms would be pants, and 1 out of 3 for your options for bottoms would be a skirt. So if I were to follow this tree diagram, right, here's my sweater, so I'm crossing my sweater first, then I'm going to pants, then I'm going to pants, and then I'm going to boots, right, because I want a sweater, pants, and boots. I have a 50-50 chance of picking my sweater, right, because I can either pick a blouse or a sweater, so that is 1/2. When I go to my pants, this tree diagram tells me that the probability of picking my pants would be 2 out of 3. And then when I go to my boots, I either can wear sandals or boots, right? So I have 2 different options for shoes, and one of them are boots. So I would have 1/2. Now, since this has the word and, this means that we are going to multiply all of these probabilities together. So if you multiply straight across the top, you have 1 times 2 times 1, which is 2. 2 times 3 is 6, times 2 is 12. So that would simplify to 1 over 6, which means I have a 1 out of 6 chance of picking an outfit where I would wear a sweater, pants, and boots. Alrighty, so that is all I have for tree diagrams. If you would like some extra help with them, please let me know. The quiz code is going to be, The quiz code is omelet. I believe the O is lowercase. O is lowercase. All lowercase. Sorry, that was a typo on my end. So if you need help or have questions on any of the questions on the quiz, please send me an email. I'd be happy to help you. Other than that, have a wonderful rest of your day. Thank you.